Okay, here's our wrap-up video for section 5.1 part 2, series of solutions to differential equations. I'm going to speed through this because it's already been a long set of videos. I know that you all have a lot of stuff to do right now, and it's just that these problems are really complicated and it's hard to get through examples in the time we have. But the types of problems we're solving are y double prime plus some function times y prime plus some function times y. You need to make sure that the method makes sense for the point around which your solution is written. For us, we always think about using it's written around x equals 0, and then we did some examples. So just to emphasize, the thing that we said we had to check was that p of x0 and q of x0 make sense. Anywhere where p and q don't make sense, tell you about where your radius of convergence is. The general approach is going to be that we assume our series solution and then we have to solve for Cn in an algebraic way. It's really similar to assuming y equals e to the mx as a solution and solving for m in an algebraic way, except that it's much more of a mess. I gave you the steps to follow, assuming our ordinary point was 0. That's what we're going to focus on because we only have so much time in the semester, but the same approach would work for different x0. We talked about these first 7 steps that kind of get you to the point where you can think about what your coefficients are. A lot of this should have felt familiar from what we did on Tuesday. And then I kind of like started the setup of a problem and then brought us back to, oh wait, finding the coefficients actually is kind of more challenging than just finding the relationships. And so I laid out these steps, which are a lot more unfamiliar to us. It's stuff we haven't ever thought about before. And so if this is the sticking point for you in these lectures, don't worry, we're going to get more practice next week. For now, if you can just get these problems started, that's enough. It's a very different topic. It's really challenging. I get that. Don't worry. Let's see. The important thing to remember when you are setting your coefficients is that you do have to assume your 2 unknown coefficients like C0 and C1. And then after that, you use your important relationships to find every other coefficient in terms of those 2 things. So we did our first example. Our 2 relationships took 2 pages to get to. Then we had a page of plugging stuff in and seeing what happens. And then in the end, we could kind of write out our solution and say, oh, well, it depends on C0 and C1. Those used to be attached to the 2 different parts of our solution. And I said, the things in brackets that are attached to C0 and C1 are your fundamental solutions. They're like your Y1 and Y2 from exam 2. Later, if we can get this working, we'll actually think about turning this back into a function. But if this is as far as we ever get, that's okay. Then we did another example. I kind of tried to go more quickly through it, but it wasn't enough. We still ended up spending a long time plugging in coefficients. And then in the end, I kind of rewrote it in that neat format, but we didn't have time to talk through getting there. Don't worry about it. So just my wrap up right here is we went over the steps to solve these problems. Finding the coefficients is really hard. We were like running through this whole video and we barely managed to do 2 examples. We actually didn't really manage. I had to take more time than you usually do on videos. Sorry about that. Our practice problem for today is I just want you to find the coefficient relationships for a series solution to y double prime minus 3xy. So what I'm saying is start with y double prime minus 3xy, like that's your differential equation. Stop here. Don't try to do the thing with all the ends that give you the coefficients. That's important for finishing the problem, but it's new stuff. So just get to this relationship and then we can talk through how we would do this part at the start of class. So go ahead and get going on that and I will see you in class.